All right, so section 5.2 talks about trigonometric functions of real numbers. And in this section, what we want to do is learn the actual trigonometric functions, learn the values of the trigonometric functions, and the fundamental identities that will help us evaluate certain cosine, sine, secant, cosecant, tangent, and cotangent values. Okay, so given a point xy on the unit circle, how do we find the trigonometric functions? What are the trigonometric functions? So here, if we take a closer look at the unit circle here, we have our unit circle and we have a point xy here, and then we have this angle theta, okay? This comes from the unit circle, x squared plus y squared equals 1. Now, the 6 trigonometric functions are cosine, sine, tangent, cosecant, secant, and cotangent. Those are the 6 trigonometric functions. Okay? Now, remember, we just discussed that the x value corresponds to what? Cosine. Very good. And the y value corresponds to? Sine. Very good. So cosine of theta is equal to x. Sine of theta is equal to y. Tangent of theta is equal to sine of theta over cosine of theta, or in other words, y over x here. Secant of theta is 1 over cosine of theta, or either 1 over x. Cosecant of theta is 1 over sine of theta, or either 1 over y. Do you have a question?
No.
Okay. And cotangent of theta is equal to x over y, which is the same thing as what over what? Very good. Cosine theta over sine theta. Okay? So one thing that you may want to write out additionally is that tangent of theta is equal to sine of theta over cosine of theta. Secant of theta is 1 divided by cosine of theta. And cosecant of theta is 1 divided by sine of theta. And then cotangent of theta is equal to cosine of theta over sine of theta. So whenever you're looking and reading through your sections at the end of the book, or at the end of the section, they talk about fundamental identities. These are fundamental identities that are presented in your book. But because I'm introducing them here, I'm going ahead and pointing that out to you. Again, tangent of theta is sine of theta over cosine of theta. Secant of theta is 1 over cosine of theta. Cosecant of theta is 1 over sine of theta. And cotangent theta is equal to cosine of theta over sine of theta. Okay? All right. So, you will need your unit circles. Hopefully you have them memorized by now. But let's go through and identify the 6 trigonometric functions for the point P corresponding to negative 1/2 and square root 3 over 2 on the unit circle corresponding to the real number T. Okay? All right. Cosine of T here is what? Negative 1/2. Good. What's sine of T? Square root 3 over 2. Good. Somebody else, tell me what's tangent of T? Good. Square root 3 over 2. All of that divided by negative 1/2. And what is that equal to? Negative square root of 3. Good. Good, all 3 of you. Okay? Secant of T. Someone else.
1 over negative 1/2.
Good. 1 over negative 1/2. What is that equal to? I'm looking for someone who has not answered. What is this equal to? So this is the same thing. I'll write in the steps to show you why. This is the same thing as 1 times the reciprocal of your denominator, which is negative 2 over 1. So that's the same thing as negative 2. Okay? If you answered, you're out for right now. What is cosecant of t?
1 divided by root 3 over 2.
1 divided by square root 3 over 2. Good. And that's also what? Someone who has not answered. No decimal values, please. What is this equal to? 2, whoops, right, is equal to 2 times the square root of 3 all over 3. Does anyone not see how to get that? Okay, so to get that, you have to rationalize. Okay, so I'm going to move this over just a tad bit. And I'm going to explain why we have that. So, an aside, 1 over the square root of 3 over 2. And this is algebra, so you have to remember your algebra techniques. This is the same thing as 1 times 2 divided by the square root of 3. That's equal to 2 over the square root of 3. But because you have a radical in the denominator, you want to rationalize. So you multiply by 1 in the form of the square root of 3 over the square root of 3. And then that gives you, so just to show you, this was added to that previous step. This is what we did. And then that's going to be equal to 2 square root of 3 divided by square root of 3 squared is just 3. So that's how we got this. Okay? What questions do you have there? Hello? No questions? Okay. What's cotangent of t?
Negative 1/2 divided by root 3 over 2.
Negative 1/2 divided by root 3 over 2. Good. And what is this equal to? Walk me through the steps. If you want it, go for it.
That would reduce to negative 1 over square root of 3.
Say it again.
That would simplify to negative 1 over square root of 3.
Very good. Very good. Because you have negative 1/2 times 2 over square root of 3. Your 2's cancel and you have negative 1 over square root of 3, but we have a radical there in the denominator. Rationalize, what does that give you in the end? Negative root 3 over 3. Good. So that is cotangent of t. Okay, so we've identified the 6 trigonometric functions for that given point P on the unit circle. What questions do you have? Okay. So our next example, example 2, find the exact values. Find the exact values of the 6 trigonometric functions of pi halves. Of pi halves. Of pi halves. So I'm asking you to find cosine of pi halves, sine of pi halves, tangent of pi halves, secant of pi halves, cosecant of pi halves, and cotangent of pi halves. You do not need a calculator for this. Remember your unit circle here, and pi halves is created by that angle, and you have this point here. This point is what? What point is that?
0,
0, 1. Good. That's pi. Oops, pressing the wrong thing. That's pi halves. Let me move this over a little bit. Okay? So what's cosine of pi halves? 0. Good. That's the x value. What's sine of pi halves? 1. What's tangent of pi halves? Ah, can you divide by 0? Undefined. Good. Undefined. Secant of pi halves? Undefined as well, because you have 1 over cosine of pi halves, which means you have 1 over 0, but that's undefined because we cannot divide by 0. What's cosecant of pi halves? 1. Good, because that's 1 over sine of pi halves. Sine of pi halves is 1. So you have 1 over 1 is 1. Do you need me to write this down? Yes? No? Okay. Yes? Okay. So you have 1 over sine of pi halves. Sine of pi halves is 1, so we get 1 over 1, which is 1. Cotangent of pi halves is what?
Square root over 1.
Which is?
1 is 0.
Which one? 1 or 0? I heard 1, I heard 0. 0. Good, it's 0. So remember, cotangent is cosine of pi halves divided by sine of pi halves. So that's 0 over 1, which is 0. What questions do you have? Okay. Find the exact values of the 6 trigonometric functions of pi over 4. Of pi over 4. All right. What is cosine of pi over 4?
1
No. It's not 1/2.
Square root 2 over 2.
Square root 2 over 2. It's square root 2 over 2. Remember, on your unit circle, pi over 4, this is the angle pi over 4. The point corresponding to that is square root 2 over 2, comma square root 2 over 2. Okay? So cosine of pi over 4 is square root 2 over 2. What is sine of pi over 4? Square root 2 over 2. What is tangent of pi over 4? 1. Good. What is secant?
1 over root 2.
I'm sorry, say that one again.
1 divided by root 2 over 2.
And simplified, what do you get? Square root of 2. Good. You get the square root of 2. Does anyone need to see that written out?
Yes, please.
Okay. So secant of pi over 4 is the same thing as 1 divided by square root 2 over 2. I'm going to need you to start writing out the steps to convince yourself, okay? That's important because this goes back to understanding the algebra part. So this is equal to 1 times what?
2 times 2 over square root of 2.
Good. You multiply the numerator times the reciprocal of the denominator. You have to remember that. You apply it all the time. So this is equal to 2 over the square root of 2. But remember, you have a radical in the denominator, so you need to rationalize. Multiply by square root 2 over 2 in the form of 1. Doing that gives you 2 square root 2 over the square root of 2 squared, which leaves you 2. The 2's cancel. You get the square root of 2. Okay, so that's secant of pi over 4. What is cosecant of pi over 4? What is it?
Square root 2.
Square root of 2 for the same reason, right? And what is cotangent of pi over 4? 1. Good. What questions do you have? Okay, excellent. So now let's talk about the domains of the trigonometric functions. Let's talk about the domains of the trigonometric functions. So your domains, typically when you're writing sine or cosine, you have sine of theta or cosine of theta. You have to have an angle of measurement that follows that, okay? So your function, sine and cosine, the domain is all real numbers. The possible x values, all real numbers. For tangent and secant, it's all real numbers other than pi halves plus n pi for any integer n. Okay, so you have pi halves and they are adding multiples of pi, okay, to that. Cotangent and cosecant, for those two functions, you have all real numbers other than n pi, okay, for any integer n, okay? So, those are your domains. Now, to know which functions are positive in each quadrant, there's a mnemonic device that students remember to help. It's all students take calculus. So in quadrant 1, all signs are positive. Quadrant 2, your sine is positive. In quadrant 3, your tangent is positive because both your cosine and sine values are negative. Here in quadrant 4, your cosine is positive. Okay? So that's how we remember that. Now, you will have to also evaluate trigonometric functions for any real number. So if it doesn't seem obvious that it's on a unit circle, then what do? You have to go through, find a reference number. Now this is connecting everything that we talked about before. You have to remember how to find a reference number. Remember, your reference numbers are located in what quadrant? The first quadrant. Good. They're located in the first quadrant. So now what you're going to do, if you're given an angle or given a if you have to find a trigonometric function for any real number, if it's not one that you can readily identify from the unit circle, then you find a reference number. Then you find the sign of it and then find the actual value. Okay? So that's what's coming up. That's what we're going to talk about now. So evaluating trigonometric functions for any real number. To find the values of the trigonometric functions for any real number t, we use the following steps. 1, find the reference number. So we find the reference number or reference angle, t bar associated with t. Find the sign. Determine the sign of the trigonometric function of t by noting the quadrant in which the terminal point lies. Okay? 3, find the value. The value of the trigonometric function of t is going to be the same, except possibly for the sign, as the value of the trigonometric function of your reference angle. Okay? So, let's find the exact value. Let's find the exact value. Given cosine of 19 pi divided by 6, what is your reference angle? What's your t-bar? What's your reference angle? Come on, you're experts at this now, right? You worked through the homework? What's the reference angle?
Pi over 6.
Pi over 6, you got it. So your reference angle is pi over 6. Okay? Now, cosine of pi over 6 is equal to what? Good, that's the square root of 3 over 2. But we were asked to find cosine of 19 pi over 6. Cosine of 19 pi over 6 lives in what quadrant? Go ahead. Say again.
4.
Quadrant 4, does everyone agree? No?
Third quadrant.
The third quadrant. Good, it's in quadrant 3. Remember here, have pi over 6. Then you have 2 pi over 6 is where? We can make that a little bit better. You have pi over 6 here. 2 pi over 6 is where? Also 2 pi over 6 is who in disguise? Pi over 3, good. So you have pi over 6, pi over 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Go back around, that's 12 pi over 6. 12 pi over 6, add 6 to it, you get 18 pi over 6. 18 pi over 6, then you go one more, you got 19 pi over 6. So you're right here. So you're in quadrant 3. Okay? So that equals cosine of pi over 6 is equal to square root 3 over 2, but 19 pi over 6, this is the notation for belongs to. Belongs, your book uses this often. It belongs to quadrant 3. So this isn't new notation. This is your books use it all. Your book uses it all the time. So cosine of 19 pi over 6 is what? Good. Negative square root 3 over 2.
Wait, what does that mean?
Again, it's belongs to. Your book uses it all the time. So this is, I'm using what your book uses often. It's been using it a lot whenever we talked about set notation and everything. So this means belongs to or is an element of. Okay, or is in. What questions do you have? Okay. Find cosine of negative 7 pi over 6. What's your reference angle?
Pi over 6.
Pi over 6, good. So T bar is equal to pi over 6. Negative 7 pi over 6 is in what quadrant? How did you get 1?
Fine. Well, if you do 6 pi over 6, that's 1.
No? 6 pi over 6 is what? 6 pi over 6 isn't 1, it is.
Pi?
It's pi.
Well, I meant like it's 1, I guess it wouldn't be 1 full cycle, it would be half a cycle around the circle.
It's half. So you're going in what direction? Clockwise or counterclockwise? Clockwise. So we're going around this way, we end up here. That's 6 pi over 6. So it's in quadrant 2. Good. It's in quadrant 2 because this is negative 7 pi over 6 right here. Okay? So this belongs to quadrant 2. Which means cosine of negative 7 pi over 6 is negative. So it's negative. In fact, we can say it's equal to what? Cosine of negative 7 pi over 6. Remember, what's cosine of pi over 6? Square root 3 over 2, right? But because we know it's in quadrant 2, we know it has to be negative, so we get negative square root 3 over 2. So you got to connect what your reference angle is, what the cosine is of your reference angle to the quadrant that the actual angle belongs to. Does that make sense? Yes or no? Okay, online, are you good? Okay, it's okay. Cosine of negative pi over 6. Reference angle. Pi over 6, good. So T bar is equal to pi over 6. Negative pi over 6 is in what quadrant? What quadrant? I can't hear you, I'm sorry. Say that again? I, ye-
Quadrant 4.
yes, good. Sorry, whenever I'm typing on the screen, I'm also hearing that, so I just didn't hear you. So it's in quadrant 4, good. So cosine is going to be what, positive or negative? Positive, good. So cosine of negative pi over 6 is going to be positive, and in fact you can say cosine of negative pi over 6 is what? Square root 3 over 2. You got it. Good. Okay? Now let's talk about even and odd properties of your trigonometric functions. Cosine and secant are even functions. All of your other functions, all of your other trigonometric functions are odd functions. Cosine and secant are your only even functions. Remember when we talked about even functions and odd functions before? Even functions are symmetric with respect to the y-axis, good, and then odd functions are symmetric with respect to the origin. Okay? Now, here, what does it mean? Sine of negative t is equal to negative sine of t. Cosine of negative t is equal to cosine of t. So when you substitute in a negative, or you have cosine of a negative angle, you just get that cosine value back. So that's even. Tangent of negative t is negative tangent of t. Cosecant of negative t is negative cosecant of t. Secant of negative t is equal to secant of t. Cotangent of negative t is equal to negative cotangent of t. Notice that all of the ones that are odd have the opposite of the original trigonometric function. Okay? All right. Fundamental identities. Fundamental identities. Other fundamental identities, again, I've already stated this at the beginning of the section, were the ones that are given by having tangent is equal to sine over cosine. Secant is 1 over cosine. Cosecant is 1 over sine. And then you have cotangent is cosine over sine. Okay? Other fundamental identities, which comes directly from your unit circle. Remember, your unit circle says that x squared plus y squared is equal to 1. Okay? So sine squared of t plus cosine squared t is equal to 1. Remember, your x is your cosine squared, your x is cosine, your y is sine. So this comes from there. Dividing everything here by cosine squared of t, you'll get the identity tangent squared of t plus 1 equals secant squared of t. Dividing everything here by what gives you this? Dividing everything by sine squared of t. Very good. Dividing everything by sine squared of t gets you this identity. So if you know one, you can find the others. Okay? So now what we're going to do is we're going to find the values of the trigonometric functions of t from the given information. And it's going to require us to use the fundamental identity here. Okay? So here, I've given you cosine of t is equal to negative 7 over 25. And the terminal point of t is in quadrant 3. Okay? So we have to find the values of the other trigonometric functions based on this information. So what do we know? We know that t is in quadrant 3. So t is given by p of negative 7 over 25, comma, y. That's what we know. Okay? Now, using this identity here, we have negative 7 over 25 squared, because we have to find out what y is, right? That y is going to represent what trigonometric function? Sine of t. Good. So we have negative 7 over 25 squared plus y squared is equal to 1. So that means y squared is going to be equal to 1 minus, when you square negative 7 over 25, you get 49 over 625. But we're subtracting it now because we're moving it to the other side. So you get minus 49 over 625. Well, this means that y squared is equal to 576 over 625. Now you have to take the square root of both sides. I see puzzled looks. Remember, 1 is the same thing as 625 over 625. 1 is the same thing as 625 over 625, and then 625 minus 49 gives you 576. Does that make sense? Did that explain the puzzle look, or was there another question?
What, leave the denominator as the 625?
I'm sorry, say it again.
Leave the denominator as the 625?
Mm-hmm. Right, because once you find a common denominator, you just subtract the numerators, leave the denominators the same. And now we take the square root of both sides. When you take the square root of both sides, you end up with plus or minus, right? So you now take the square root of both sides, which means we have y is equal to plus or minus. The square root of 576 is what? 24, good. And then the square root of 625 is what? 25. Now we're in quadrant 3, right? Okay, since we're in quadrant 3, since we are in quadrant 3, y is what?
Negative.
Oh, I heard positive, I heard negative. Which one? Negative, good. Since we're in quadrant 3, y is negative. Remember, quadrant 3, you're over here. So you have negative, negative. We can say y is equal to negative 24 over 25. So, now when we can write out our 6 functions. We already know cosine of t. We just found sine of t. That's equal to negative 24 over 25. What's tangent of t? What's tangent of t? 24 over 7. Good. Remember, you take sine and divide it by cosine, and then you get 24 over 7 because your denominator cancels with this. Okay? Now, what is cosecant of t? Come on, what's cosecant of t? It's 1 over what? 1 over negative 24 over 25. Good, so that gives you what? Taking 1, dividing it by a fraction is the same thing as saying take 1 and multiply by the reciprocal of it. What do you get? I'm sorry, I didn't hear you.
25 over 24.
Positive or negative?
Positive.
Good. Negative 25 over 24. Good. Secant of t is what? 1 over negative 7 over 25. Simplify, you get what?
Negative 25 over 7.
Negative 25 over 7. Good. And then cotangent of t is the same thing as cosine of t over sine of t. Oh, I wrote cotangent. So cotangent gives you what? Negative 7 over 24. Be careful. You're taking a negative. Where's your cosine? You're taking a negative and dividing by a negative. So that should be a what? Good. Everything else is right. So a positive 7 over 24. Good. What questions do you have? Okay. Part B. Part B. Same idea, different problem. Here, I gave us the cosecant of t is equal to 5, and cosine of t is less than 0. Since the cosecant of t is equal to 5, and cosine of t is less than 0, we're in what quadrant? T is in what quadrant?
Second.
Which one? I heard second, I heard third.
Second.
Why?
Wait,
So think about what you have. Cosecant is the same thing as 1 over what?
sine.
It's the same thing as 1 over sine, okay? But it gives you positive here. So can it be quadrant 3?
Yes.
It can be. Sine is what here?
Oh,
Positive or negative?
it's negative.
Ah, remember your, right. Quadrant 3, you have negative, negative. Quadrant 3, you have negative, negative. So because you have negative, negative here, it cannot be quadrant 3. But you know, since cosine of t is less than 0, it cannot be quadrant 1 or 2, or quadrant 1 or 4. It has to be quadrant 2 here. Because here, you have cosecant of t is positive, which means your sine value has to be positive, whatever t is. Okay? So, t belongs to quadrant 2. Sine of t is equal to what?
1 over 5.
1 over 5. Very good. How did you know it was 1 over 5?
Because the cosecant of t is 5 and is the same thing as 1 over sine.
That's right. Very good. Very good. Do you need me to explain that one more time?
Yes, please.
Cosecant of t is the same thing as 1 over sine of t. Right? If cosecant of t is equal to 5, then that means that sine of t has to be 1/5, because 1 divided by 1/5 is equal to 5. Okay, so sine of t is 1/5, and you can say t is p of x comma 1/5. Okay, so we need to find x. To find x, we use our fundamental identity. So you have x squared plus 1/5 squared equals 1. So you have x squared is equal to 1 minus 1 over 25, which means x is equal to x squared is equal to 24 over 25. Why? Because remember, 1 is 25 over 25. And then you take the square root of both sides. So that gives you x is equal to plus or minus. The square root of 24 is the same thing as 2 square root of 6. Square root of 25 is 5. So on the side, the square root of 24 is equal to the square root of 4 times 6. That's the square root of 4 times the square root of 6, which is 2 the square root of 6. Okay? Now, we already know that cosine of t has to be less than 0. So we know x has to be negative here. Okay? So we get cosine of t or we can say x, cosine of t, which is the same thing as x, is equal to negative 2 square root of 6 over 5. Okay? Now we can find our other functions. We already got sine of t. Okay? We have cosine of t. Tangent of t is the same thing as sine, 1/5, divided by negative 2 square root 6 over 5. That's the same thing as 1/5 times 5 over negative 2 square root 6. These 5's cancel out. So that leaves us with 1 over negative 2 square root 6. But again, we have a radical there, right, in our denominator, which means we have to rationalize or multiply by 1 in the form of square root 6 over square root 6. When you do that, so you multiply by square root 6 over square root 6. When you do that, you get square root 6 over, what's square root 6 times the square root of 6? 6, good. So 6 times negative 2 is? Negative 12. So you get square root 6 over negative 12, or you can say negative square root 6 over 12, or you can put the negative out front. Either one. Okay? Now, secant of t. Secant of t is also 1 over what? Come on. 1 over what? 1 over cosine of t. So you have 1 over negative 2 square root 6 over 5. So what does that give you? Come on. You don't have to rationalize it right away. Tell me what you get initially. 1 over what? Negative 2 square root 6 over 5. Good. Now that gives you what? Go ahead. 5 over negative 2 square root 6. Good. And then you rationalize by multiplying both by square root 6 over square. I can talk. You multiply by 1 in the form of the square root of 6 divided by the square root of 6, and that gives you what?
Negative 5 root 6
over 12. You got it. So let's just separate these two so you know they're not the same. Good. Okay? One left. What do we have to find? Cotangent of t. Good. So cotangent of t is equal to what over what? Over 1/5. So that's the same thing as what? Negative 2 root 6. Good. Right? Because when you multiply by 1/5, your 5's cancel. You got it. What questions do you have? All right. So that is section 5.2, trigonometric functions of real numbers.